Welcome to this movie about smart technology migration. So we're going to walk you through how we facilitate migration from a legacy platform to a new platform, and do so in a semi-automated way. And what we're looking to do is automate many of the things that today, with any migration, tend to be much more manual. And the aim of doing this automation really is an efficiency gain. It gives you better time to market and reduces the cost of doing the migration. So the way that we do it is we listen to the voice of the machine. We harvest what we call the session instances, or the business transactions, from observations, and those observations come from the log files in a pre-production environment of the system that we're looking to migrate. So then when we've got a set of these session instances, these observations, and the business transactions that we can glean from those and how those play out over a system, we can translate that into an as-is model, and we can actually generate what we call the session type, which is the model from all of the instances that we've got. And obviously the more instances we have, the more robust that model is, that session type, in representing what actually the voice of the machine has told us in terms of what it's able to do. And we can validate that as-is model, the session type, against the session instances. So we can test all of the session instances, the business transactions, to make sure that we've got the correct model going forward. And then once we've got the as-is model, we can start to incorporate new requirements, what we might consider to be the voice of the machine. And we can actually test our old session type, our old as-is model, against those session instances, the business transactions. And what we should see is that the new requirements are not met by the session type, the model. And that will give us an understanding of the scope of change, where things need to be changed in the model and therefore the running system, in order to incorporate these new requirements. And because we're able to test the model against the requirements as business transactions, we're able not just to do the scope analysis, but we're able to double check that the new model, when we transition it to the new model for the new requirement, also meets all the existing old requirements that are still valid. And that gives you far better time to market and far less risk in terms of a misdelivery. So, and this is the principle of what we call validating the 2B model against all of the session instances, the business transactions, the requirements that the system now needs to meet in the future. So the way that we do this is we harvest the log files and translate that into a model. There's an intermediate step where we look at the sequence diagrams to generate that model, and that model could be a choreography model or a BPMN2 model. And when we look at more at the detail of the technology, we'll actually generate BPMN2 models. And then what we do is, once we've got that model, we can use that model to generate and deposit into the ESB for the communications, the business process into the BPMN engine, the business rules into the rules engine, the monitoring details into the monitoring engine, and any orchestrations into the BEPL engine, and so on and so forth. And that's essentially how we do it. So let's have a shift, and let's actually look at this technology as it's live. So this is the way that we harvest log files. We're going to sign into a tool called SDP, and then we're going to pick a log file and load it into the system. So that's all we're going to do at this point. So I'm going to click on the upload button, tell it it's a WPS log, and then go and browse my my disk. As you can see, I've got a log file here, and then we'll just ask to upload that particular log file. Okay, so now that the log file has been successfully submitted, we can click on the link that's displayed, and here we can see that this is the log file that was just loaded. If I click on the log file, I get the session name, so this is the session instance, the business transaction. If I click on the business transaction itself, then I'm going to get a display of a sequence diagram, as you can see, and we can navigate across the sequence diagram and see what happened. This one's verifying payment instructions, so it's doing all the usual things that you would expect, and we can scroll down and see all the systems that are touched. And we can equally click on any of these little ovals and see that section of the log file that was relevant to that particular communication between these two parties here. And that's essentially how we do the reverse engineering of the session instances for any system. So these same sequence diagrams can be represented in Eclipse, as what's called a scenario. So here's an example. So this is a successful loan application. Same principle, but this is Eclipse now. And we switch from the web-based tools to the Eclipse tools because it's in the Eclipse tools that we're actually going to create a model. So in this instance, we've got 3 sequence diagrams, one successful loan application, the other's insufficient credit, and the other's customer unknown. So from here, we really need to create a model. So if we select all 3 and then select the appropriate option to generate the BPMN architecture, we press the create button and then we give it a model name. So I'll call this complex lending, and we go and tell it where we're going to put that complex lending. So we've got to go and navigate to the appropriate folder. So I'm just going to do that now. So I think it's probably complex lending, and this will be the as is model. So we'll open that folder there, and we'll see something appear in here in a second, and then we can have a look at the model. So here's our complex lending. Here's the model that was generated at the top level. So we can have a look at the BPMN diagram. So there's a request for the loan, and then there's a credit check, and so on. So and this has the endpoint views of the same thing. So this is what the individual participants do. There's 4 of them, and in the BPMN model as a whole, it gives us the overarching choreography between all of them, and that's essentially how the BPMN works. So now that we've got these, it would be nice just to double check that this actually is the correct model. So we can go back to our scenario here, and we can ask to simulate this. So we play the scenario across the model to make sure that that's correct. So I'm just going to make sure that we're pointing to the right model, complexlending.bpmn, and we are. And I can now simulate that. And if the model meets the requirement, then this will go green, and we'll see all the links and everything go green. And there we go. So that's all gone green. So we know that that works. Now that's all well and good, but what about the case where we have a new requirement? So imagine we've got a new requirement which we could have created either in the web-based tool, or we could create it actually by hand. Here's an example. So this is a new successful loan application, and the difference between the successful loan application and the new successful loan application is between these two. So in the bank swim lane, which is the bank participant in the process, after the credit check we just do a delivery of the loan, whereas in the new loan application we confirm their rating prior to the delivery. So we've added a new communication here which would suggest change. Now it's easy to see this in this example because it's so simple and trivial. What we can do here, just to double check, is we can test this new requirement against our as-is complex lending model. So that's already set up for us. So when we simulate this, what we should see is some red bits, and the red bits precisely identify what needs to change, and the green bits that are the bounding parts between the red bits suggest where in the swim lane it needs to change. So in the bank component, it needs to change after the credit check response is received. It needs to then send out the confirm rating and wait for the response. And in the logistics, rather than starting off with a delivery request, now it expects to get a confirm rating prior to delivery, then it expects to get the delivery request. So we can see that there's 2 places it needs to change. So now that we've identified those changes, what we can now do is we can take the new scenario, and we can take all of the old scenarios, leaving this one unselected, and we can create a model from that too. So this would be the equivalent of our 2B model. And this is without us having to actually create the model. So we'll call this complex lending as well. But in this case, we'll put it in a different place. So we'll put it in the 2B. And we'll open that and press OK. Right, so here's the 2B model. And what we should see is this additional step of confirming the rating prior to delivery. And we can see that here's a confirm rating here and here. So this is the new model. If we simulate this again, we'll clear it, but this time change it to be the 2B model, then we should see this go green. Right, so now if I simulate this one, it should go green. And this would prove that the new model supports the new requirement. And again, we can go to the insufficient credit, and we can make sure that that works too. So we're regression testing. It's already pointing to the 2B. So this makes sure that it supports the old requirements. And there you go, it's gone green. And if we go back to the original successful loan application and we try and simulate this against the 2B, we should see that it doesn't work. So we'll just do that just for completeness. And we should see it failing somewhere here. This is going to be out of sequence for a start. There we go. So we can see that that's out of sequence now. And that's because the new model doesn't support sending of the delivery request to the logistics, which also doesn't support the receiving of that request until after these other two things have happened. So that just shows that it actually really works. So now what we can do is we can export this BPMN2, and we'll export it as a zip file because that's what BlueWorks Live likes, and that's what we're going to actually drop the BPMN2 into. So this is complex lending, and we're going to drop that into my home directory. I'm going to overwrite whatever was there because we don't need it, and then I'm going to switch. So now I'm going to switch to BlueWorks Live. So here's BlueWorks Live, and I've got a smart technology migration workspace, and I'm just going to import. What I'm going to import is the BPMN2 notation. Press next, and then browse and go and find my in my home directory my complex lending .zip. So here we go, complex lending.zip today 12:05. So that's it done. We press the import, and it's going to import all of the appropriate BPMN2 files. So I can look at, for instance, the bank. If we look at the bank, that's a good one to look at, which will pull up a diagram in BPMN2, but this time through BlueWorks Live, and we could actually enact the process. So you'll see here that it's got the confirm rating prior, which is what we expect the bank to do. So it's going to send that message. And if we went back and had a look at the logistics process, we should see the equivalent of that, because we'd be looking then at the receiving end of the same send. So if we go and have a look at the logistics, just to confirm that this is correct, that's the receive, and here's what it sends back. So that's the response back. So that's just to show you that it works, and now we could actually do playback on these BPMN2 diagrams and have it running in the real IBM BlueWorks Live BPMN2 engine. So I hope you've enjoyed that. Thanks very much for listening.